Okay, so now we're going to look at this limit summit notation. And so we're going to be using these beautiful things right here. The e's, which is a sigma. And again, that means to sum. Sorry, that was supposed to be quotes. Just like we knew that the integral was telling me to sum. Okay, both of these symbols here mean to keep adding to sum up these parts of things together. Okay, and when we get into Calc BC, we're gonna love seeing these in more detail. So here we're gonna have the definite integral, and we're gonna see this summation, excuse me, with Riemann sums. Okay, so we knew that this was a Riemann sum. So it looks like, it's kind of taken it in different pieces of however they did this Riemann sum. But this is a Riemann sum. And here it was broken up into 4 intervals, and I can see they look like they have equal widths. So we're going to call that width delta x, okay? And we're going to look at this from like sum A to B. So if I take that width and I make it closer and closer and closer and closer together until I get it so super close together, we're looking as they go to 0, because once we get them closer and closer to 0, we're just looking at all these infinite lines that actually have no width that we add together to get a whole big area. But yes, okay, and so how do I do that? I take the height, which is f of that x value, times the width of the delta x. So, and I keep doing that until I reach the amount that I need to, or as we can see, we're going to want to keep going infinitely in order to get the exact area. So if I am taking this guy to 0, I know that I need to take n towards infinity. So I have infinite number of those Riemann sums in there, of those parts. So instead of just doing 4 parts like we did here, 4 subintervals, I'm going to have an infinite amount. Okay? And then we're going to take f of the value times the delta x. And a lot of times you're going to see instead of n's, because it's like, oh, we've got n too many times, you're going to see it with a k or an I, all right? So we're going to say k is going to 0, or sorry, k is going to infinity, and then have the sub k. So there's different versions that we can see here, but that is telling me that I am integrating. This is the one that I like to use. Okay. That's the one I like. This is the one I use. Okay, long day. So basically, we're going to look and we're going to say we are going and dividing it up into n subintervals. So I'm going to take this b minus a and divide by n. That's going to give me what my width is. This is going to be what I always kind of have to look at first, is finding that width. So in this case, then I could say that my x sub 1 is going to be where I start, and then I'm going to add on my delta x. My x sub 2 is going to be what that value was, right? So here's like x sub 1, and then I add on my delta x. X sub 3 is going to be what that value was, and then I add on my delta x. So I'm increasing by this delta x each time. So let's look at this one, okay? So the first thing I'm going to do is find my delta x. So I'm going to take my b minus my a, so minus a negative, and divide by n. So I can see that I have 2 over n. Then I'm going to find my x sub 1. So my x sub 1 is where I start, and then I'm going to add 2 over n. And then I'm going to find my x sub 2. It is going to be where I just had it, and then I'm going to add my delta x, right? Each time. X sub 3 is going to be what I just had, And then I'm going to add on my delta x, and I continue this process. So I can kind of see that my x sub k here is going to be -1 plus, if I was at 3, I had 1, 2, 3 delta x's. When I was at 2, I had 2 delta x's, right? So here we can kind of say I'm going to have k times that delta x of the 2 over n. Okay, so I know f of x, they told me here, was x cubed. So I need to find x sub k plugged into this now. So this would be -1 plus k times that 2 over n, all cubed. So we're almost there. We know that we want to take the limit as n goes to infinity, where I can start at 1 to the n, and then I'm going to do my f of x sub k times my delta x. Okay? That looks bad. That's hard to see. That's as n goes to infinity. Okay. So let's look at this. It says, what is this equivalent to? So let's go ahead and do our steps. First, find your delta x. Oh, look at that. It's the same thing. Oops, n. Then I'm going to find my f of x sub k. So in this case, I know that I'm going to take it to the fourth. My x sub k is my 3 plus my k times 2 over n. And then I'm going to write my limit summation. N goes to infinity. K equals 1 to n. F of x sub k times delta x. Okay, so this right here, these were my steps. So let's look and see at some of the things that went wrong. Here, I can see, oh no, this should be 2 over n for sure. So automatically, I know that this guy did bad. And it looks like he also forgot the 2 here for the 2 over n. So he said that the delta x was 1 over n. Wah, wah, wah. And this person, they got the 2 over n here for the delta x, but they didn't get it here. They did not get that part right there. Wah, wah, wah. Okay, student C. She said the 2 was good here, but left it off here. Wah, wah, wah. And student D, which is you, because you're going to get these, you had the delta x was 2 over k, or 2 over n, and you have the 2 over n here with your k for that delta x. You did it right. Ah! Okay, so for this next one, here it says that there is an error at some place here, and I want you to find what the error is. All right, so let's look at the first one. What's my delta x? Delta x is 5 minus 4 over n. They did their delta x wrong. Not 5, that's a 6, isn't it? That was hard to read. 6 minus 4 over n. Your delta x should have been a 2. Then everything else would be correct. Where you start, plus 2k over n is the same as 2I over n. Like I said, sometimes they use i's, sometimes you use k's, sometimes they use n twice, and it's horrible. I like to use the k with the n, but sometimes they do the I. Okay, let's look at this one. Here I can see that I have my delta x, 7 minus 2 over n. That's good. And then I look in the inside. I'm only going to plug in like that x sub k here. And so I do 4 times my x sub k, and then what the heck? They squared it? That is where they went wrong. Everything else is right. Okay. Actually, there's one more thing wrong here. Did anybody see the other thing? Oh, we didn't start at 4, we started at 2. Ooh, that was also wrong. 2 wrongs. Here. Okay, let's look at this one. 4 minus 3 is 1 over n. My delta x is good. So here my x of k is I start at 3, and then I'm going to do my 1 over n times my k, or i's in this case, and then I'm going to go plug it into these two x's. So 6 times 3 plus 1 over n times the I, that's fine. And then, oh no, they cubed it and they should have squared it. Let's see if the rest is right. I almost left off that one, so I'm going to check it in detail now. Plus 3 times this x of k, 3 plus 1 over nk, or I, which is the same, and the rest is completely right. So we're okay with that one. The only thing wrong was they put a cube instead of a square. Okay, let's see if you can find the mistake on this one. I cannot read that value. 8. Okay, so this is 5. Is that really 8? Oh, or is that 9? No, that's 9. Okay. Oops. So this is 5 until 9. So 9 minus 5 is 4 over n. That part's right. My x sub k would be where I started, plus 4 over the n times the k. I plug that into my x. 8 minus 2, no, they put a 4, so that should have been a 2. And then I plug in my 5 plus 4, and then the rest looks good. Okay? All right. So now we're going to go a little bit backwards. Here they have given me the limit of the Riemann sum, and I want to write a definite integral. Okay. So here, if I look at this, I can see this is what I'm plugging in on the inside. There's no plus. So there's no like 5 plus that amount or 2 plus that. So it means I had to have started at 0. So then I know that if I ended, I have to have a plus b, in this case, has to equal 6. And if I started at 0, then b would have to end at the 6. So there's that part. And then we're going to see that we have the square root of 2 times x plus 1, and then the dx. And then whatever I plug that into, that's where my x goes. Okay, so let's try this one. Here I can see I started at -2. I have it. And so I know that I have to end at 5. So a plus b has to equal 5, and I started at -2. So b will have to be 7. No, I just did that backwards. Hold on. I have to add to 5, and I started at -2. Yeah, that was right, 7. Okay, -2 plus 7 will give me -5, or +5. No, I just did that backwards. Leave me alone, people. I can do math. The difference has to be 5. Why am I adding that? The difference. B minus A has to equal that. All right, my bad. Corrected now. That is definitely not a 7. The difference has to be 5. So let me go back up here. B minus A had to be 6, and we said A was 0, so B was 6. B minus A has to be 5. I don't know what I was just thinking there for a second. And we said A was -2 minus the -2 has to be 5, so that's a +3. That B would equal +3. There we go. Sorry about that. All right, and then I can see that I have x squared. That whole thing is my x minus 3 dx. All right, I've got this. I started at 1, and I need 5. So b minus a is 1, and this is 5. And I'm subtracting my a is 1, so b is 6. And does that distance equal 5? Yes. Does that distance equal 5? Yes. Does that distance equal 6? Yes, that's what we're doing. Okay, so then that's my x part. So I have 3x minus 4 dx. Okay, this one, start at -2, have to total 6. So I would end at 4. Then I have x cubed dx. Parentheses part is my x. Okay, started again at -2. Need to go 2. And then I have the square root, x squared plus 1 dx. Started at 5. Need to go 4 more. No, I did not start at 5. Gotta look at that a little bit better. I started at 2. And then I need to go 4 more. So now that's 6. Now that's 5x plus 7 dx. All right. Got this. So now we're going to go one step farther. We are going to write what the definite integral is, and then we're actually going to go calculate it with some geometry. So first thing, I want you guys to see if you can write the definite integral now. So go ahead and pause me and see if you can get this. Okay. So I kind of need to look up here to see where I'm going to start and stop. And so if I'm looking at the -2, here's where I am -2. And so I actually want to take this from 12 to 16. So this one was a little bit different that way. Otherwise, I'd say from 0 to 4, but that one doesn't have the -2. Okay? This one, it looks like it is 4 minus, so here's the 4, and then minus this area going on here. So that is happening from 4 until, I can't see that, from 3 until 8, 9. And then that's kind of how you had to do these. So this one was a little bit different. So see if you can keep filling in. This one is 0 to 3, -2 to 0. That's a 0, yep. And this one was from 9 to 12. And this one ended up from 16 to 22. And then we actually just get to go find those areas using some geometry. So this one's pretty easy. And we know it's all below, so it's negative. So base times height, -8. This one right here, I am looking for this area. So I'm going to do the rectangle minus this semicircle going on. And I got 24 minus 9 pi over 2. See if you get the same thing. And I'm going to go ahead and fill these in. I want you to try them. And then let me know if you have questions. We can finish more in class if you had questions over these, but that's the end of day 2. So I hope that you guys liked this. You will have this on your AP exam of knowing how to write these and going back and forth as well as on your test. So if you are struggling, let me know. I'll put up some extra review. Good job, guys.